Welcome to week 3, simplifying fractions. Yes, what we've all been waiting for, kids. As you've noticed, we've gone from a black background to a green background to celebrate our school colors this week. I'm also going to use some fall color ink, too, to keep us in the mood of the fall. All right, let's move along. What does it mean to simplify a fraction? You may want to take a moment and press pause and simply write this sentence down. Okay. Simplifying a fraction means to reduce it or to make it as simple as possible. Let's try an example. Say we were to simplify 4/8. It's pretty much common knowledge that 4/8 is equal to 1/2. It's a very popular example. But why is that? What I'd like to draw attention to is the fraction bar. Sometimes students ask, where's the fraction bar in a calculator? And we say, well, it's kind of a funny question. It's the division sign. Why? Because when we're looking here, this is actually 4 divided by 8. And this is 1 divided by 2. And I have an equal sign to show that these are equivalent fractions. We call these equivalent fractions because they may look different, but they have the same value. When you actually go to your calculator and you take 4 and divide it by 8, 4 divided by 8 is equal to 0.5. 1 divided by 2 is equal to 0.5. When you simplify fractions, if you want to know, is my answer right, the easiest way to answer that question is to do the division on both fractions. If you get the same answer, you have reduced them or simplified them in the correct fashion. Your answer isn't always going to be a nice, pretty number or a nice terminating decimal, but the answer should be identical in nature. Let's try method number 1, to evenly divide both the top and the bottom number. So if we're going to simplify 12/20, a lot of students will look at 12 and 20 and say, well, those are both even numbers, so I could divide them both by 2. So we'll divide top and bottom by 2. And what we end up with is 12 divided by 2 is 6, 20 divided by 2 is 10. Now, have we simplified the fraction? In part, we have, but we're not as simple as it could possibly be. We can still divide top and bottom by 2. And when we do that, we end up with 6 divided by 2 is 3, 10 divided by 2 is 5. So now we have 3/5. And I'm wondering, could I divide by anything else? Well, 3 is prime, can only be divided by 1 and 3, and 5 isn't divisible by 3, so I guess that's it. Now how could we check? I believe that this is the reduced, most simplest form of 12/20 that there is. If you want to check an answer, at first when you're feeling unsure, divide 12 divided by 20, then take 3 and divide it by 5, and see if you get the same answer. Go ahead, try it out. Press pause. Did you get 0.6 both times? Hopefully. So our final answer for the process of simplifying 12/20 is 3/5. Method number 1, though, sometimes has us doing lots of work. I mean, imagine if the original fraction was, say, 120 over 200. We don't want to sit there and divide by 2 eternally. That's kind of a waste of time. Which brings us to method number 2. Method number 2 is using the greatest common factor, right? Or otherwise known as, the GCF, right? Greatest common factor. So sometimes we get a little crazy with these acronyms and we forget the formal names. What's most important here is that you understand what a factor is. A factor is just simply a number or a set of numbers that you can multiply together to get another number. So what is a number that I can multiply times another number to get 12, and I can also use that number to multiply times another number to get 20. That's kind of garbly, but the bottom line is, what are some of the biggest factors of 12? So I know that 12 is 1 times 12. I know that 12 is 2 times 6. I know that 12 is 3 times 4. And that's that. I know that 20 is 1 times 20, 2 times 10. I know that it's 3 times nothing, 4 times 5, and that's that. Now, out of these two lists, are there any in common? Well, sure. There's 1 is in both lists, 2 is in both lists, 4 is in both lists. Which one of those is the greatest, the largest? 4. If I divide 12 by 4 and I divide 20 by 4, I'm left with 12 divided by 4 is 3, 20 divided by 4 is 5. And I'm arriving at the same answer I did in the previous page, or the previous screen rather. We already know that this is the correct answer. So what's the difference? Method number 2 just yields us the correct answer faster. Sometimes you thought you had the biggest number. Sometimes you don't even give it a shot. You just start infinitely dividing by 2 or 3 or 5. What's critical is at the end, when you look at your simplified fraction, that you make sure that it truly cannot be reduced anymore. Just keep checking, even when you do believe that you have the GCF, the greatest common factor. Let's try a few more examples. Example number 1, 48 over 54. What goes into 48 and 54? Well, 2 does. Well, you know what? Let's try something bigger. I know that 48 is 6 times 8. Is 54 6 times something? Yes, it is. 6 times 9. So it looks like 6 goes into both of these. So I'm going to divide by 6 on top and bottom. What am I left with? 48 divided by 6 is 8. 54 divided by 6 is 9. Do 8 and 9 have any common factors? Nope. So this is our simplified answer, or if you choose to, circle it. You should have a method of identifying the actual final answer. You can't just keep having a string of fractions. You want to make sure that you actually identify your final answer. It's very important in a math class. If not given a direct spot to place a final answer, make sure that you've indicated it by circling it, underlining it some way. Maybe something like this is a little over the top. Okay, well, how about simplifying 18/24? So right off the bat, maybe we'll say we jump out and we say, oh, I know, 3 goes into both of those, and 18 divided by 3 is 6, and 24 divided by 3 is 8. Well, be careful. Although we didn't just start by dividing by 2, I look at 6/8, and they're both even numbers, so definitely can be divided by 2. And if we divide top and bottom by 2, because now that is the GCF, we're left with an answer of 3/4. Well, that's our final answer. Again, we can check that 18 divided by 24 is indeed 0.75, and 3 divided by 4 is also indeed 0.75. And just for the record, 6 divided by 8 is 0.75. So all of these are equivalent fractions. 3/4 is the simplest version. But what could we walk away from? Well, the next time we see 18 over 24, maybe we take a look at, we had divided by 3 and divided by 2. What's 3 and 2 are factors of what number? Or 3 times 2 gives you what value? You say, well, 6. Take a look at the original problem. 18 over 24. Had we divided by 6 on top and bottom, that would have yielded us an answer of 18 divided by 6 is 3. 24 divided by 6 is 4. And there you have it. So up here was more of a method number 1. Maybe I didn't intend for it to be method number 1. Over here, this was more of a method number 2, using the greatest common factor. Now, up at the top where I said, I didn't think, initially I thought 3 was my greatest common factor, and that's why we have to work on our multiplication skills. So all of this really does come together. Just like if you can't add integers, then it's tough to combine like terms. If you don't know your multiplication tables, it's tough to simplify and deal with fractions. And we're going to be riding the fraction train for a couple of more weeks now, so let's get on board. No pun intended. How about simplifying improper fractions? Simplifying improper fractions is the same as simplifying proper fractions. What makes this improper is that the top value is larger than the bottom value, or the numerator is greater than the denominator. In middle school, we would have changed this to a mixed number, but in the high school, you're going to realize that we're okay with improper fractions. We'll just leave them as is. All we want to do is just simplify it. So we're going to attack this in the same fashion as we did proper fraction. Our idea here, right, working off of method number 2, we're really looking for the greatest common factor. So you say, well, 63 is divisible by 3, and so is 27. Well, if something's divisible by 3, I would encourage you to go a little bit larger. How about another multiple of 3, like 9? Does 9 go into 63? Yeah. 9 times 7 is equal to 63, and 9 times 3 is equal to 27. Since 9 is a factor of both of those, then that is going to be our greatest common factor. Sorry about that, 9. And as we have over here, 63 divided by 9 is going to be 7, and 27 divided by 9 is going to be 3. 7 and 3 are both prime numbers, so this must be the simplified version. And again, if you divide 63 by 27, and you divide 7 by 3, press pause, see what you get. Did you get 2.3 repeating on the decimal piece? Right, the 0.3 repeats. Like I said at the beginning or earlier in the video, that it's not always a nice answer, it's not always a pretty answer, but the fact of the matter is that they are identical answers. 2.3 repeating is the same is equal to 2.3 repeating, which makes these two fractions equivalent fractions. And because 7/3 cannot be reduced anymore, we've satisfied the simplify procedure. Again, I cannot stress doing all of this without a calculator. That's how we're going to quiz it. That's how we expect you to be able to do it. Later on, when you get to Algebra 2, all the calculators in the world aren't going to save you. You need to know your multiplication tables. Yes, multiplication tables. Know them, love them, live them. See you next week.